Here is a short tutorial on how to answer question 1 of the daily stoichiometry practice, okay? So, it says, in a chemical reaction, 20 grams of sodium hydroxide is mixed with 30 grams of hydrochloric acid to produce water and sodium chloride. So what do you need to do? You need to identify limiting and excess reagents, calculate the mass of the excess reagent, and calculate the mass of one of the products, which is sodium chloride, NaCl. Okay? Now, excess means extra. That means that reagent was not fully used. Okay? So the first step every time you do a stoichiometry question is to balance the equation. So let's write the equation. It says in a chemical reaction we have sodium hydroxide plus hydrochloric acid gives us water and sodium chloride. Okay. So how do we balance it? We can count. So we have sodium, oxygen, hydrogen, and chlorine. On the reagent side, okay, so this is the reagents, these are the reagents, and these are the products, okay? So we have one sodium atom, one oxygen atom, two hydrogen, and one chlorine. On the product side, we have one sodium atom, one chlorine atom, two hydrogen atoms, and one oxygen atom. So this is already balanced, okay? Now, some of you ended up with 2, 2, 2, and 2. So if you look at that, you can still simplify it because all of your coefficients are divisible by 2. Okay? So if all the coefficients are divisible by 2, you can still simplify it. So 2 divided by 2, 1, 1, 1, 1. Okay? So if you counted properly, you would know that this was already the balanced equation. Okay? So let's write down the reagents. So we have sodium hydroxide and hydrochloric acid. Mass. Mass is how many or how much we used for the reaction. So it says we got 20 grams of sodium hydroxide and 30 grams of hydrochloric acid. Okay? So the next step we have to do is to calculate the MR, molecular mass, or relative atomic mass of sodium hydroxide and hydrochloric acid. So sodium hydroxide, so let's look at this one. Sodium, okay, has a molecular atomic mass of 23 plus oxygen 16 plus hydrogen, which gives us a total of 40. Okay, so 23 plus 16 plus 1 gives us a relative atomic mass, or MR, of 40 grams. Hydrochloric acid. Hydrogen has an atomic mass of 1. Chlorine has 35.5, which is a molecular mass of 36.5 grams. Okay? Now, let's calculate for number of moles. And as we know, the number of moles is equal to mass, okay, mass divided by molecular mass or atomic mass. In this case, it's 20, okay, 20 divided by 40, which gives us 0.5 moles. And this one, 30 divided by 36.5, gives us 0.82 moles. Okay, make it a habit to round to 2 dp, 2 decimal places, okay? Now, it says, use the ratio to determine how many moles of hydrochloric acid needs to react with the number of moles of sodium hydroxide. So we are basing this on sodium hydroxide. So we need to use ratio. So let's look over here. Sodium hydroxide has a coefficient of 1. All of them have coefficients of 1. So that means all of them are 1:1 ratio. Okay? So we can do 1. Okay, so this is sodium hydroxide. 1 molecule of sodium hydroxide is equivalent to 0.5 mole. Okay? 1 molecule of sodium hydroxide is worth 0.5 mole. 1 over 0.5, which should be equal to 1 hydrochloric acid over X. Why are we doing this? Because we want to know if the amount of hydrochloric acid, okay, is enough or too much. So you can start with hydrochloric acid, but you can figure out which is the limiting and excess by just seeing if the ratio is correct. Okay, so we are basing it on sodium hydroxide. 1 over 0.5 equals 1 over X, and X is the number of moles of hydrochloric acid that you need to react with 0.5 mole of sodium hydroxide. Okay, so cross multiply, you have X is equal to 0.5 mole. Okay, so that means we need 0.5 moles of hydrochloric acid to react with 0.5 mole of sodium hydroxide, because it's a 1:1 ratio. So if sodium hydroxide is 0.5, therefore you also need 0.5 mole of hydrochloric acid. So let's look at the comparison here. You have 0.82 mole over here. See, 0.82 mole of hydrochloric acid, but you only need 0.5 mole. Okay, you have 0.82 mole of hydrochloric acid, but you only need 0.5 mole. So which one are we using here? Have is greater than what you need. That means what you have is a lot more than what you need. Therefore, the excess reagent is hydrochloric acid, because you have 0.82 mole, but you only need 0.5 mole. And therefore, your limiting reagent would be sodium hydroxide. This means sodium hydroxide will get used up, and there will still be hydrochloric acid left over. Okay? So let's look at the next one. Calculate the excess or extra moles of the reagent. Okay? We need to know how many. So, how many moles of the excess reagent do we have? How many moles of hydrochloric acid do we have? We have 0.82 minus how much do we need? 0.5 gives us 0.32 moles. Okay? Excess. Too much. Okay? Now, how do we calculate for the mass? So we know the mass of excess moles is 0.32 times the molecular mass of hydrochloric acid, which is 36.5 grams, which will give you a total of 11.68. Now, depending on how you rounded, some of you rounded 0.3, some of you rounded to 3 dp. Okay, so let's make it a point. Let's just round it to 2 dp. So if you answered 11.68 or 11.753 or 11.8, okay, that depends on how you rounded. Okay, so if you round it to 2 dp, it should be 11.68. Lastly, calculate the mass of sodium chloride based on the ratio of the limiting reagent. So we need to use the ratio of sodium hydroxide because that's the limiting reagent. So let's calculate for the moles, okay? So we know, okay, over here, that all of them have only a coefficient of 1. So it's a 1:1 ratio. But I just want to show you the calculation, so next time, if it's not 1:1, you know what to do, okay? So 1 molecule of sodium hydrochloride has 0.5 mole equal to, so this is sodium hydroxide, and this would be sodium chloride, 1 over x. So x is equal to 0.5 mole. And how do we get the mass? We need the MR of sodium chloride, which is, okay, this one is 23 plus 35.5 gives you 58.5 grams. And to get the mass is equal to MR times the number of moles, okay? So this would equal to 58.5 grams times 0.5, and the answer is 29.25 grams. 29.25 grams. Okay? So, as you can see, this sheet is really scaffolded. It teaches you step by step. Please read it carefully. And everything else, the following question, the question number 2, is the same procedure. Okay? Apply the same procedure. Round to 2DP. Okay? And I hope this helps you so that you can be stoichiometry experts. Okay? Bye-bye.